it's kind of a unique product. We'll bring it up on the screen, but just for like, I was expecting a rubber mat. This is different. So am I looking at it? Which way does it go? Is this it?
Well,
flat?
yeah, it can be used in different orientations. So you can use the mat and lay it flat on top of.
This is flat though, right?
Yeah.
Yeah. Okay.
Yeah. This is just a model, right? A 3D printed model.
Right.
So it's made out of plastic, but
this would be rubberized.
It would be rubber, and the mats are laid down on top of the blasts. Mm-hmm. Underground, though, in an underground environment, you could also be using a mat in a vertical application where you put it and hang it along the walls, or you hang it in front of the face where they're going to blast, so that all the material doesn't come back and damage equipment, etc., that may be on the walls.
Right.
And that is another place where the Manta mat can excel.
So is this a model of the Manta?
No, that's an Armadillo.
That's an Armadillo. Okay.
That's an Armadillo, and then this one here is a Rhino mat. So the Rhino mat.
Oh, I see. So that one, this is rubber sort of compact together, whereas this has got these curvatures. Is this right? The accurate thickness and everything?
Yeah, this is actually designed to scale. So it would be 10 feet wide by 15 feet long.
Right.
So that's the form factor. So whenever we print them, if we print them, we print them to scale.
Okay.
Anyway, it was designed so that we could bring them to the show, right? Because it's kind of hard to bring a 10 by 15 mat here.
But is this saving on material? What is making this lighter?
The reason that the Armadillo is a lighter mat than the Rhino mat is that the Rhino mat treads weigh approximately 25 kilos per tread, whereas a row of Armadillo pieces or tire pieces would probably weigh, the equivalent thickness would probably weigh about half of that,
right, and
or 2/3 of that.
And depending on the application, you can spec it for their use.
Right, and we can compress them more so that we get a denser mat, and we get different densities throughout the mat as well. So we could have a 50% higher density in the center of the mat than we would on the ends of the mats.
Oh, I see.
So we have variable density throughout
going back
the mat.
to just trying to lighten the shipping if you're trying to get it across country or across the US.
Or even the application. So, one of the applications, and the reason we came about our patent for the US and Canada about 4 years ago is that we had a request from one of the US military bases to build a product that would allow them to detonate ordnances that were, according to what we were told, lobbed back and forth, and then they'd end up maybe not detonating, and they'd be 6 feet underground.
Right.
So they then needed to drill a horizontal borehole to the ordnance to allow them to detonate the ordnance.
Wow. Okay.
And what they wanted to make sure of was that there was no blowback that came out of that borehole.
Right.
And so they wanted a mat that would stand up vertically instead of horizontally, that was light enough that they could move it around,
right,
and that they could handle it with light equipment, which the Rhino would not accommodate, right? Yeah. And so we designed a variable density product so that we had very high density in the center of the mat versus on the sides of the mat to minimize the weight, but maximize the impact protection, right, or the throughput.